So today we are going to see another question. Erythrocyte sedimentation rate. It is a common hematology test performed using blood containing anticoagulant. It measures the rate at which the red blood cells in the sample of the whole blood falls to the bottom inside the specific tube under gravity. This sedimentation is due to the rouleau formation, where RBCs form a stack because of their discoid shape. Which of the following statement about ESR is correct? So ESR, erythrocyte sedimentation rate. This is nothing. It is the rate at which the erythrocytes, that is the RBC, is falling down under the force of gravity. Now, we have to know just a basic thing. That is the RBCs. These RBCs have a negative charge around them. Okay, this negative charge around them, and which is also known as the zeta potential. And due to this negative charge surrounding the RBC, it never clumps together in the normal state. Okay, it do not stack, and there is no rouleau formation in the normal state. Now let us understand. Now let us see that only this funda can help us to answer the question by negating. Let's see. Inflammatory conditions cause increase in the acute phase proteins in the plasma that causes the RBC to repel from each other to form stacks. No, it cannot be wrong, because RBCs repelling each other, RBC cannot form stack. So this is absolutely making no sense. Next, increasingly positively charged plasma proteins increases the neutralization of the negative charges on the surface of the RBC, which allows the formation of rouleau. Yes, this can be possible. Third, bacterial endotoxins in the plasma inhibit platelet aggregation, causing RBC to clump. How come it can be possible? Because there is platelet aggregation, there is fibrin formation, there is clot formation, and how inhibiting platelet aggregation causing RBC to clump? This cannot be possible. This is absolutely making no sense. Anticoagulants in the blood increases the negative ions in the plasma, which increases charges on the RBC membrane and is causing them to stack and form rouleau. How come increasing negative charge on the RBC membrane help them to stack? So this is not also possible. So I think this can be the answer. And yes, this is the answer. Now let's understand it in more details. Inflammation. When there is inflammation in the body, then what happens? Then there are some fibrinogens. Okay, some fibrinogens are released, which is actually a positive acute phase protein. This coats the RBC, and as a result, the negative charge in the RBC decreases. There is RBC aggregation, and there is rouleau formation. This happens normally. Denser the RBC aggregate, faster it falls within the pipette tube. Yes, so denser the RBC aggregate, faster it will fall into the pipette tube. And so there will be increase in the ESR, because ESR is nothing but the sedimentation rate. Now let us see in which condition the ESR increases and where the ESR decreases. ESR increases in case of infection. In case of inflammation, we have seen due to these acute phase proteins. In most anemias. Why in case of anemias? Because in anemias, the amount of RBC is less. There are less negative charges, right? There is a tendency to clump. In pregnancy also, there is anemic condition prevailing. ESR decreases. That means the RBC is not falling down fastly. Okay, RBC are falling down slowly. In sickle cell anemia, due to the altered shape, the RBCs are not clumping together and they are falling down slowly. In case of polycythemia, there is excessive RBC, there are excessive negative charges, so the ESR is also less. Now coming to the normal values, for adult male, it is less than 15 mm per hour. For adult female, it is less than 20 mm per hour. Why for female it is slightly more than the male? Because female has a in case of females, actually the hemoglobin is low comparison to males, because in males the testosterone hormone, it stimulates erythropoiesis, but in females the estrogen inhibits erythropoiesis, and there is a monthly menstrual loss. Now let's know more about this acute phase reactants. These acute phase reactants are nothing, so they are just released during the time of inflammation, any infection in your bodies. Some positive acute phase reactants, it can be C-reactive protein, ferritin, fibrinogen, haptoglobin, hepcidin, procalcitonin, serum amyloid A. For the negative, we have albumin, transferrin, transthyretin. So this is all we knew about ESR and how we solve the question just knowing this simple funda. I hope you liked it. Stay tuned.